Good day. We'll discuss measures of center and other locations for ungrouped data only. So measures of center. Measures of center, or more colloquially, averages, are the most well-known measures of numeric data. They are single values intended as representatives which can neatly characterize the whole group. So although it is just a single value, then of course we can make an interpretation to the whole group of data that you have gathered. Thus, trade unions, when negotiating pay increases, often use an average wage as a standard on which to base those increases. So we have three most commonly used measures of center: the mean, median, and the mode. So what is mean? It is an arithmetic mean, or simply the mean, is the most popular measure of center. It is just a sum of a set of measurements, or your data, divided by a number of measurements in the set. So we have here the sum of all your numerical data divided by the total number of numerical data. We also have this weighted mean. It is an average computed by giving different weights to some of the individual values. So we have the sum of the product of the weights and your data divided by the sum of the weights. So usually when you compute your GPA or your grades, the average grade that you have, we use this weighted mean. We have these properties: may not be an actual value of the observation in the data set. So say for example, if you have 1, 2, 3, 4. So if we add this or get the mean, 1 plus 2 plus 3 plus 4 divided by 4, because there are 4 of them, this is just equal to 10 over 4, or 2.5. So 2.5 is not on the set. So that is why it may not be an actual value observation in the data set. Number 2, it can be applied in at least an interval level of measurement. Of course, it is easy to compute. Number 4, every observation contributes to the value of the mean. This is because all of the data are included in the computation. All of them. Every observation is part of the computation. And subgroup mean can be combined to come up with a group mean. So we have an example later about this number 5. And number 6, it is easily affected by extreme values. So if we have 1, 2, 3, 4, the mean here last time is 2.5, but if we add 100, so if we have this as our data, so plus, 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 and now this is divided by 5. This is 110 over 5, so this is now, I think this is 22. No, so it's very far, so it is easily affected by extreme values. So if there are only 4, it's 2.5, but now I just added an extreme value, which is 100, it becomes 22. So the mean is easily affected by the extreme values. This is because of number 4. Every observation contributes to the value of the mean. Okay, so let's have an example. Find the mean weight of this population data. So we have 2, 4, 6, 8, 10. So all we need to do is to add and then divide the number of data. 1, 2, 3, 4, 5. So we have 30 over 5 equals 6. Number 2, we have this data. So we have 1, 2, 3, 4. So only 4. So 101 divided by 4, we have 25.25. So do not round off the mean to a whole number, because it is expected that when we compute a mean or average, most of the time it has a decimal number, or it is fractional. Okay, number 2, Juan de la Cruz grades in biology, chemistry, and physics are 90, 95, and 88 respectively. What is his average of these 3 subjects if the credit units are 3, 5, and 4? So basically, the credit units are the weights of these biology, chemistry, and physics subjects. So this is an example of a weighted average or weighted mean. So solution, of course, is the product of the weight and the data. So 90 times the weight 3 plus 95 times the weight 5 plus 88 times 4 divided by the sum of the weights. We have 3 plus 5 plus 4, which is equal to 91.42. And last, this is an example of property number 5. When the sample mean can be combined to predict the population, to compute for the population mean. So a sample of 40 students took 40 entrance tests. So there are 40 students. Out of these 40, 15 had a mean score of 75. The other students had a mean score of 90. So the question is, what is the average score of these 40 students? So of course, there are 15 students who got 75, a mean score of 75. The mean score of the 15 students is 75. And of course, the remaining 25, 40 minus 15 is 25. The mean score is 90. The other students had a mean of score of 90, or the other, so meaning the 25 other students. So divided by 15 plus 25, or the number of students. So therefore, the average of these 40 students is 84.38. Okay, so you may answer these questions, and the answers are provided. So you may provide your own solution. Okay, now let's go to the median. Median is just the middle value. No? So if it's a middle value, of course, we need to arrange your data. As much as possible, for me, it's better if it's increasing. So if the number of observation is odd, then meaning we only have one middle value. But if it's even, then we have two middle values. So say for example, we have 1, 2, 3, 4. This is even. There are 4 data. So if it's even, there are two middle values, the 2 and 3. Because the middle value or the median is somewhere in between. So all you need to do is to get the average of these two. So 2 plus 3 over 2. So this is 2.5. So the median of these 4 data is 2.5. So if you notice, the same with the mean, the median may not be an actual value of the given data set because 2.5 is not there. Okay, so that is why we have the first property. Number 2 can be applied in at least ordinal level because of course we have arranged the data set. And of course, it is a positional measure. And in an ungrouped data, it can't be affected by extreme values. But in grouped data, because of the formula, it may be affected by extreme values. But since we are concentrating on the ungrouped data, so the median is not affected by extreme values because it is a positional measure. So we have an example of number 3 later. Okay, number 1. Find the median for the data in the following list. So we have this data. So what is the first step? The first step is to arrange the data. So arrange the data. So this is now the arranged data. So count the number of data. 1, 2, 3, 4, 5, 6, 7. So 7 is odd. So if it's odd, then we have a middle value, only one middle value. So usually I do this. If it's odd, I just add 1. So 7 plus 1 over 2. So this is 8 over 2. So it's 4. Meaning it's the fourth data. So 1, 2, 3, 4. So meaning the median is 9. Next, you have this. So again, arrange the data. So 1, 2, 3, 4, 5, 6. There are 6 numbers or data. So if this is even, so I usually do this. 6 divided by 2 is 3. So the median, therefore, is shared by the third and fourth data. So 1, 2, 3. So here, the data is somewhere in between. So we'll get the average of 77 and 89. So 77 plus 89 divided by 2 is 83. Therefore, the median is 83. Okay, number 2. The median of the rank list is 11. If the maximum value 37 is increased to 55, meaning I will change 37 to 55, what effect will this have on the median? So increasing or changing the maximum, or this 37 to 55, has no effect to the median, as the median is a positional measure. Say for example, I will change this to 55. Is there a difference? No, because the median is still the fourth one, so which is still 11. But of course, when you go to group data, we have a computation or a formula there, so I guess there is an effect. But here, since we're dealing with ungrouped data, so it is just a positional measure. It has no effect to the median. Okay, so again, median is just the middle value. So you may answer this. And we have these answers for numbers 1, 2, 3, and 4. Okay, last measure of center, the mode. It is just the value that appears the most, or the most frequent number of times that appear in the set of data. It may not exist. No, if all of them existed only one, so there's no mode. And if it exists, it may not be unique. So it can be 2, 3, or more mode in a given data set. So that is why number 1, it can be applied or used for qualitative as well as quantitative data. It may not be unique. It is not affected by extreme values, because we'll just count the data that appears the most. We are not solving anything. And last, can be computed for ungrouped and grouped data. So exercises, find the mode for the data in the following list. Okay, for number 1, we can see here that there are 3 15s. So 1, 2, 3, and there are 2 21s. So we will choose the most frequent. So the most frequent here is 15. Number 2, all of them existed only once, so there's no mode. Number 3, 3 uh, existed five times, 4 twice, 5 is 3 times. So the most frequent is 3. And last, 12 twice, so we have 2 12, and then 71, we have 2 71, the rest once. So therefore, the modes are 12 and 71. So it may not be unique. Now let's go to the measures of other positions or locations. So fractiles. Fractiles are values which are obtained from equal subdivisions of data. The subdivisions into 4 equal parts, 10 equal parts, and 100 equal parts are called quartiles, deciles, and percentiles. So in this case, so if uh, the median is the 50%, right? Because it is at the middle. So the median therefore is equal to the 50th percentile. Okay. When we go to decile, the median for decile, so we have D1 to D10. So the median, of course, the middle is D5, or the 5th decile. And for the quartiles, so 4 divided by 2 is 2, so we have the median is at the second quartile. This is Q, second quartile. So the median is equal to P50, D5, and Q2. So now let's go to percentile. So a percentile or P sub k or the kth percentile is a measure used to indicate the value below or equal which a given k percentage of observation fall. So take note below. So if we consider a line and this is your P sub k, the area here or the percentage of this area is k percent, okay, to the left. So for example, the 90th percentile or P sub 90. So this indicates that the area below or equal, which is 90% of the observation may be found. So this means that 90% of the observation are found below P sub 90 or the 90th percentile. Meaning above is 10%. So let's have some exercise. So according to the US Department of Labor, as of May 2009, the median annual salary for a physical therapist is or was 7 for 74,480. So say for example, I will draw a line for visual. So at the middle, we have the median. So this is the median, the 74,480. Okay, and then the 90th percentile, so somewhere here, because the median is at P50. Okay, P90 is somewhere here. So this is now the location of the 105,900. So the question is, find the percent of physical therapists whose work or whose annual salary was more than 74,480. So the answer is 50%. How did we get 50%? Take note, when we say P50 at the median, 74,480 is at the median, so it's at P50. So meaning the area here or the percentage to the left is 50%. So since we're talking about more than, so it's on the other side. So if this is 50, of course, the other side is also 50%. Okay? So the answer for letter A is 50%. Now next, less than 105,000. So less than means to the left. So this is the $105,900. So this is at the 90th percentile. So automatic when we say 90th percentile, it means this is the percentage to the left. So meaning it is 90%. So to the left of P90 is the 90%. And last, 74,480 and 105,900. So it's at the middle, so this area. So we'll just have 90 minus 50, so we have 40%. Number 2, on a reading examination given to 900 students, Elaine's score of 602 was higher than the scores of 576 of the students who took the examination. What is the percentile for Elaine's score? So visual, let's have a line. So there are 900 students. And Elaine's score is somewhere here, maybe, say for example here. So this is 602. Her score is 602. Now we will locate this score. This is the score of Elaine. So we will see what is the rank of Elaine, what is her percentile. So take note of this, that Elaine's score was higher, so meaning he's higher than the 576 of the students. So if she is higher, of course, the 576 are lower than her. So the 576 students are below her, below or equal to her. So meaning this is already to the left of 602. So to get the percentage, we'll just divide 576 by 900. So 576 divided by 900 times 100% is equal to 64%, meaning the percentage here is 64%. And based on the definition of percentile, it is the area below or the percentage below. So therefore, this is P64. Or Elaine's score is at the 64th percentile. Okay, we'll have some first is you may practice this. We have some answers here. Okay, so practice. And then we'll have some additional problems. So on a placement examination, Rick scored lower than or equal to 1,210 of the 12,860 students who took the exam. We must find the percentile of Rick. So this is the solution. So how did we get that solution? So Rick scored is somewhere here. So you may put anywhere, no? Anywhere. So say for example, this is Rick's score. And according to this, Rick's score is lower. So lower. Maybe it means he is the lowest among this one. Lowest. You may consider him lowest. So lower meaning is the lowest. So meaning 1,210 is on this side. Not on this side, because if it's on this side, it means Rick's score is higher. Okay, it's higher, but it says lower, so the 1,210 is on this side. So if we compute the percentage here, so we have 1,210 divided by 12,860, it's 9%. So this is therefore rounded off to 9%. But the question is the percentile. When we talk about percentile, it should be the percent to the left. Okay, to the left. So to get the percentage to the left, we can just subtract 9% from 100%. So 100% minus 9% is 91%. So therefore, the area here, the percentage here is 91%. So meaning the percentile of Rick's score is 91, or at the 91st percentile. Number 2, Kevin scored at the 65th percentile on a given test to 9,840 students. So meaning Kevin's score is here and at the 65th percentile. So it means that the percentage here is of course 65%. Now, how many students scored lower? So when we say lower or lower than or equal, so it means it's this part. Okay, so it's on the left part. So look at that, it's 65%. So all you need to do is to multiply 0.65 and 9,840. Okay, and the result is 6,396. So meaning there are 6,396 students who scored lower than or equal to Kevin. Okay, last additional example. So Renee scored at the 84th percentile on the test. So 84th percentile. So P84. It means the percentage here is 84%. How many students scored higher than Renee? So if this is 84%, higher than Renee's score must be 16%. Okay, we're talking about higher, so all you need to do is to multiply 0.16 by 12,600, and the result is 2,016. So meaning there are 2,016 students who scored higher than Renee. Okay, so this is percentile. Now let's go to quartile. So the three numbers q sub 1, q sub 2, and q sub 3 that partition a ranked data set into four equal groups are called quartiles of the set of data. So if we distribute or divide this, so we have the median. So we have the q1, the q2, and the q3. So actually q2 is the median, as what we've discussed. Okay, so q2 is the median, so at the center. Q1 is actually the median also, but of course with this lower data. Okay, it's also the median, the center of the lower data to the left of Q2, and Q3 is the median to the right of Q2. Okay, they are all medians, but the main median for the whole data set is Q2. Okay, so all you need to do is to rank the data, then find Q2 first. After finding the Q2, you get the median of the lower value or values, which is to the left of Q2, and you find the median of the data to the right of Q2. So for example, we have this. Find the quartiles of the following data. So these data are already arranged, so in this way, horizontal. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2, 20. So there's no value here, so meaning there are 19. Okay, there are 19, what do you call this one? Set of data. So 19. So this is odd, so meaning we have only one middle value. So where is it? So since this is odd, I may add plus 1. 20 divided by 2 is 10. So it's at the 10th. So meaning 29 is our Q2. Okay, the 10th data. Now to find the Q1, so we must count all the data that is at the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So at the left of Q2, so it's 9. So again, it's an odd number, so you may add 1 and then divide by 2. 10 divided by 2 is 5. So the data is at the 5th. 1, 2, 3, 4, 5. So this is therefore your Q sub 1. And on the right side, it's also the fifth term. So 1, 2, 3, 4, 5. So this is your Q sub 3. So the first quartile is 11, the second quartile is 29, and the third quartile is 104. Okay, next example. So we have 5, 10, 15, 20, 24. So 24 divided by 2, this is 12. So since this is even, the median is shared by the 12th and the 13th data. So 1, 5, 10, 12, 13. So somewhere here. Okay. So that is Q2 is 42 plus 43 over 2. That is 42.5. Okay, so that is the median. Okay, now let's count the number of data to the left and to the right. So to the left, we have 1, 2, 3. Okay, there are 12 data. So even again, so 12 divided by 2. So it's 6. So it's shared by, Q1 is shared by 6 and 7th data. So somewhere here. Okay, so obviously that's both of them are 39. So 39 plus 39 over 2, it is still 39. Q sub 1. And last for Q3, we have to the right of 42.5, we have 1, 2, 3, 4, 5, 6, 7. So it's somewhere here. So Q3, therefore, or the third quartile is 49 plus 50 over 2. So this is 50 is equal to 49.5. So Q1 is 39, Q2 is 42.5, and Q3 is 49.5. So again, you must arrange first the data and then find the median or Q2 and then find Q1 and Q3. So you may practice this. So there are 15 weights of avocados in ounces. So for number 1, practice these 15 weights. So this is for odd, an example, or your turn for odd. The number of data is odd. For number 2, you may delete 16.2. Okay, so that the number of data is even. So these are the answers, so you may check your answers. Okay, now let's go to the in general steps in finding P sub k, D sub k, and Q sub k, the percentile, decile, and quartile. So again, we need to arrange all the data from smallest to highest, and then we'll solve for the index or the position or location. That is, we have to solve for the location. So we have this k times n over 100. N is the number of data. K is the percentage, this one, the subscript. And then if it's percentile, then of course it's 100 subdivisions. So we'll divide it, the product, by 100. If it's decile, by 10, and if it's quartile, it's by 4. Not by 40, it's by 4. It's typo error. And then please take note of this. So if you have watched other videos in finding the PK, DK, and QK, they also have other procedure for number 3. But of course, let's just follow this for my class. Let's just follow this step number 3. Okay, because others don't follow this. They have other strategy for number 3. So if the index obtained in step 2 is not a whole number, meaning fractional, then of course we'll just round it up. So meaning if it's 10.1, so we always round up to 11. Okay, if there is an extra decimal number, of course we always round up, not off. And if it is a whole number, then we need to get the average of the data. No, the kth percentile is the average of that corresponding value in your data set and the value that directly follows it. Say, for example, you've got 10. L is equal to 10. So your P sub k, therefore, is just the average of x sub 10, which is L equals 10, plus the value next or directly follows it. What is the number or the data that follows x sub 10? It's x sub 11. So divided by 2 to take the average. So to understand this clearly, let's go to our examples. So suppose we have these 25 test scores. So n is therefore equal to 25. So it's already in order. So find the following: the 20th, 90th, 20th percentiles, first and third quartiles, and fourth and seventh decile. So let's have the solution. So this is already arranged. These are already arranged. So solution for the 90th percentile, of course, we need first to compute for L. So this is K times N. So our K is 90 and our N is 25. So using your calculators, we have 22.5. So since this is a fractional or decimal number, so we will round this up. So this is 23. So meaning P sub 90 is at the 23rd location. So let's count. So this is by 10. So 10, 20, 21, 22, 23. So P90 is therefore 98. So meaning 90% of the data falls below or equal to 98. Okay, I repeat, 90% of the data falls below or equal to 98. Take note, when we say percentile, always below or equal. Now next, for the 20th percentile, again, we'll use this. So the result is 5. This is a whole number. So if it's a whole number, we'll get the average of x sub 5 and x sub 6. So x sub 5 is 1, 2, 3, 4, 5, 62. And x sub 6, the data that follows it is 66. So 62 plus 66 divided by 2 is 64. Meaning 20% of the data falls below or equal to 64. Next, let's go to quartile. So the first quartile, so this time we'll divide it by 4 because only 4 subdivisions. So 6.25, this is a fractional or decimal number, so always round up. Even that is 2, we always round up. So 7. So hence, the first quartile is at the 7th data. 1, 2, 3, 4, 5, 6, 7. So 68. Meaning 25%, since this is quartile, no? So by 25%, 25% of the data falls below or equal to 68. Now, why is it 25? Because 100% divided by 4 is Q1, therefore is 25%. So another 25% here, so 25, 25, 25. That is why at the median it is still 50%. The same with P50. So I repeat, so Q1 is here. So there's only 25% here. So 25% of the data falls below 68. Now Q3, so I have this 18.75 fractional, so round this up to 19. So the 19th data, this is 1020, so 19 is 89. So how do we interpret this? So Q1, Q2, Q3. So somewhere here, this is Q3. So we have 25, 25%, and 25%. So add this, we have 75%. So meaning 75% of the data falls below or equal to 89. So meaning this data here to the left of 89. And last example for decile. So whole number. So 100 divided by 10 is 10. So this is a whole number. So meaning we'll take the average of the 10th and 11th. So 70 plus 71 divided by 2 is 70.5. Now since this is decile, every subdivision is 10%, right? 10%. So since this is D4, so D3, D4, there are 4 10%, right? So meaning there is 40%. So 40% of the data falls below or equal to 70.5. Again, 40% of the data falls below or equal to 70.5. And last for D7, so again, this is rational or fractional, so we'll round this up to 18. So D7 is therefore at the 18th, so this is 19, 18, so 88. So this is 7, so there are 10% per subdivision, so 7 times 10 is 70%. So 70% of the data falls below or equal to 88. 70% of the data falls below or equal to 88. Then you may practice this, and the answers are given. Okay, so thank you for listening.